going fairly fast here. How do we calculate the average? Of course, we then sum the values of the discrete random variable times the probability of that, and that gives us the expected value of the discrete random variable, so that's the mean, and the variance is defined as given here. So the expected value of having the random variable minus mu, the mean squared. So there we once again do the sum of the differences squared, so the difference between the discrete random variable and the mean squared times its probability. And the sum of that, of course, the square root of the variance is the standard deviation. And so this is a little example just to indicate how that would work. So we have two new product designs, and the marketing division has given its advice, and I think that's design A. They think they can make $3 million. Design B is not so clear to them. There's a probability of 0.3 that the revenue from B will be 7 million, and 0.7 probability that it will be only 2 million. Which design would you choose? Solution given here, X is the revenue from design A. There's no uncertainty, so we can say it's 3 million. Alright, so the expected value in case design A is 3 million. In case of design B, we have to apply our rule to find the mean. So we multiply 7 million with 0.3 and 2 million with 0.7, so we get 3.5. And so we see that, of course, the expected value of design B is higher than that of design A. So we could go for design B if you look at the means. The variability, of course, is larger in B. In A, there's no variability. It's a fixed value. So we calculate the variability or the variance of design B is 5.25 million by doing 7 minus 3.5 squared and so on times the probability. And so our standard deviation would be 2.3 million. Okay. So then the question is, what would you decide to go with A or with B? Any idea? What will you choose? If you're the boss of the company? So if you cannot afford to lose, you should choose a safer design. Right. So say you're the CEO of the company and you get a bonus if your revenue is higher than the expected value.
But what happens to me if we lose?
Fired. They get fired.
Only me or other people?
Oh, okay. All right. You get fired.
Me?
Yeah.
Then I choose the riskier one.
You would choose a riskier one. Okay. You don't want to know how much your bonus is. Okay, so yes, it's not an easy. We could go on like this for some time. So it's not an easy choice, but I think you're right. It depends on how much risk you are willing to take, which way you go. All right. So let's look at some important discrete PMFs. So an important one is the binomial distribution. This